Hello everyone. The topic of this presentation is KS normality test. First, we will talk about what is KS normality test, and then we will use two different ways to run the test in SPSS, and finally to report the result in APA format. KS normality test is short for Kolmogorov-Smirnov test. It examines if our data are likely to follow some distribution in some population. It should be noted that there are two kinds of KS test. The first one is one sample KS test. Another one is independent samples KS test. When we say Kolmogorov-Smirnov test, usually we refer to the first one, the one sample KS test. It tests if a variable follows a given distribution. Here, the given distribution is usually, but not always, the normal distribution. Here we have an example. Let's say if we have 1 million people population, then we randomly choose 233 samples to test their reaction time of a test. We want to find out if our data are normally distributed or not. Here is the histogram of our data. If we draw a normal distribution line here, we can find out the difference. The red areas show the differences between our data distribution with the normal distribution. In statistics, it calculates the percentage of the difference. That is the percentage of the red area. This percentage can tell us to what extent the difference it is. Our null hypothesis is that the data is normally distributed. If it is true, the percentage of the red area should be very small with a large p-value. Reversely, if the percentage is pretty large with a small value, then we can reject the null hypothesis to conclude that our data is not normally distributed. This is the easiest way to understand how normality test works. But in SPSS, it works differently. It uses the cumulative relative frequencies. Here, these two lines stand for the normal cumulative relative frequencies and the observed cumulative relative frequencies. It calculates the maximal difference between these two lines. In our case, the biggest difference happens when the reaction time goes to like 950 milliseconds. So the difference is 0.48 minus 0.41. The d-value, the d-value is 0.073. If you don't understand this, it's okay because thanks to SPSS, we don't have to calculate the d-value manually. We just get the d-value with a few clicks. Okay, now let's see the different two ways to test the normality. The first way is the non-parametric tests. We go to the legacy dialogues and then we choose one sample KS test. Another way is to examine the variables. It's also under the menu of analyze, descriptive statistics, and then goes to explore. Okay, now let's run the tests in SPSS. This is our data. We click analyze. Goes to non-parametric tests, then legacy dialogues, and choose one sample KS test. Here we move our data to variable list, and let's see. It's okay. This is the KS test result. Here, we can see the test statistic is 0.073. It is just as same as we have calculated in our slide. But how do we determine this difference? Is it statistically significant? Then we go to the p-value. Here the p-value is 0.005. It is smaller than alpha, so we can reject the null hypothesis. We can conclude that our data is not normally distributed. Let's use another way to test the normality. We go to analyze descriptive statistics and then explore. We move the reaction time to dependent list. In statistics, in plots, we take the normality plots with tests, and then we continue. Here, as we can see, the d-value, the test statistic, is as same as the value from the first way here, 0.073. And the p-value is also the same. But the difference between these two ways is that by examining the variable, we also get the result of the Shapiro-Wilk test. Although the significance value between these two normality tests are different, but we can get the same conclusion because both the p-value are smaller than alpha. But in our case, we look at the first one. We look at the KS test because the sample size of our data is larger than 200. And then finally, we report our in APA format, we will write something like the Kolmogorov-Smirnov test indicates that the reaction times do not follow the normal distribution because the p-value is smaller than alpha. We reject the null hypothesis. Pay attention to that the d-value here, the test statistic is our d-value. And then here, the degree of freedom, it equals to the sample size, and then the p-value. Okay, that's all for the presentation. Finally, we have two questions to discuss. First, how do we know which test to apply for testing normality? Do we use Skewness and Kurtosis or GS test or Shapiro-Wilk? Another one is, if the data are not normally distributed, what do we do? Thank you.